Dear students, hope you are great. Today we are going to take chapter 4, Forces and the Law of Motion. First, we should know the meaning of force. What's meant by force? Force is the push or pull. Any object at rest needs a force to get it moving. Moving objects need a force to change its velocity. Force is a vector, so force is a vector. Have both magnitude and direction. Have magnitude and direction. Magnitude, which is mean quantity, and direction. The magnitude of force can be measured using a spring scale. Look, this is a spring scale. This is an instrument used to measure a force. Force can be called acceleration. The SI unit for force to measure force is Newton, so we use a Newton to measure a force. Force can be acted through a contact or at a distance. Force diagram. The effect of force depends on both magnitude and direction. The force is a vector quantity. Diagram that show force vectors as arrow are called force diagram. So we use arrow like this to describe force that act on an object. So force diagram that show only the force acting on a single object are called free body diagrams. Look at this picture. We have here three forces act on the car. Act on this car. Force, this is force of car. Downward force of gravity, Fg, force of gravity, and here force of fraction of this tires. In force diagram, vectors arrow represent all the factors acting in a situation. Free body diagram show only the force acting on the object of interest, in this case the car. Free body diagram, we have different kinds of forces: force of gravity, force of tension, force normal, which is mean force of the object, force fraction, force push. A small object lie motionless on a floor. If you have a motionless object like this object affected by two forces: force normal, which is force of the object, force of gravity downward, which is mean force of gravity. Small object hang motionless from a rope. If you have an object hang it like this, so it's affected by two force of gravity and force of tension. An object is sliding across a smooth floor, no friction, at a constant speed. This object affected by two force normal, force of object, and force of gravity, also force of gravity. An object is sliding to the right across a rough floor, which is mean with a friction, and slowing down. So this object affected by force of friction, force normal, force of the object, and force of gravity. An object is being pulled by a rope to the right on a smooth floor, no friction. So it's affected by force of normal, force of object, force of gravity, and force of tension, as this object is pulled by a rope, like this. So it's affected by force of tension. An object is being pulled to the right by a rope, pulled like this, so affected by force of tension on a rough floor, so has a force of friction with a friction at constant speed, also affected by force of gravity and force normal, which is mean force of object. An object is being pushed to the right, so affected by force push. Okay, on a rough surface, so affected by force of friction, and accelerating to the right, which is mean toward the right, and also have a force normal, which is force of object, and force of gravity. An object that has been tossed up into the air just after it was released, ignore air resistance. There is no air resistance, so affected by a force of gravity only. An object has been tossed up into the air at a very top of its trajectory. Ignore a resistance, so affected only by force of gravity. An object in the air falling to the floor with no resistance, affected also by force of gravity. Sum of forces acting on an object is the net force. So what mean by net force? Net force is a vector sum of all forces acting on a body. So all forces acting on a body, which is mean force, a net force. Look, for example, here, this girl push this piano by force 25, and this boy pull by force 25, so by force 20. So what is the net force? Net force is sum of all forces acting on a body. So the sum or net force here, 25 plus 20. This is a net force equal 45. This is a net force. Look at this picture. This dog pull a rope with force 10, and this dog pull with force 12. So what is the net force? 12 minus 10. There is opposite in direction. Both dog pull in opposite direction. Pull in opposite direction. So 12 minus 10 will be 2. 2 to the right, toward the right. This dog has more force than this one. Here 12, here 10. So 12 minus 10 equal 2 to the right. If this force balances with the same force, for example, this dog has force 10, and also this dog has force 10, so 10 minus 10 equal 0. This means the rope do not move. That's it. Thanks for watching.